Hello friends, welcome to my channel. Let's have a look at problem 859, body strings. In this video, we're going to share a solution based on a simple algorithm. So first, let's note that this problem is a follow-up problem for problem 1657. First, I'll read through the problem statement to digest the task, and then we look at the analysis or algorithm, and then we share the code. So for this problem, I guess writing clearly the logic hierarchy is important. First, let's look at the problem statement. Given two strings S and Go, return true if we can swap two letters in S so that the result is equal to the Go. Otherwise, return false. So here in this problem, it implicitly tells us that we need to do at least one swap, right? Or exactly one swap. So here are three examples. So in example 1, so we can swap the two letters at index 0 and 1. So we get, so the output is true. And in the second example, so all the letters in the corresponding positions are the same. So because A and B are different letters, so we cannot swap. So if we swap S, we are going to have BA, which is not AB. So in this case, we are going to return false. So in example 3, so all the positions correspond to the same letter. So in this case, because the two letters are the same in S, so we can make a swap. It's identical to S, and also it equals Go. So in this case, we should return true. So it's interesting or illuminating to compare example 2 and example 3, right? So with that said, let's look at the constraints. The first constraint is on the length of the string S and Go. So they are in between 1 and 2 times 10 to the power 4. However, notice that it's not guaranteed S and Go share the same length. So this is the first constraint. For the second constraint, it basically says that the characters in S or Go is lowercase English letters, right? So with that said, so we are ready to do the analysis. So the algorithm is the following. So we'll consider it as a two-step procedure. So the first, we are going to check if the string S and Go have the same length. So if yes, we can continue. So otherwise, so we just need to return false, because if they are with different lengths, then it's impossible to achieve another one by a swap. So this is step 0. So step 1, so after we check the length, then in step 1, so S and Go should have the same length. Then what we are going to do is to check how many indices I on which so the two strings have different characters. So we are going to call this number count, right? So in the process, actually, we can do early stopping, right? If count is greater than 2, so we need to return false. So now let's look at the generic idea first. So if count equals 0, right? So in this case, so you can think of example 2 and 3, right? So in this case, we need to check if there is a character in S which appears more than once. So in this case, we can swap the two positions corresponding to two occurrences of the letter in S or equivalently in Go, right? So this is corresponding to I guess example 2 and example 3. So here I also cooked up one example, right? So AAB, they are the same, so the count is 0. However, so we can swap the first two letters AA, right? So in this case, we should return true. So if the count is not 0, then we just need to consider if it's not 2, so we are going to return false, right? We need more than one swaps. So here is one example. In this case, the count cnt equals 1, right? So if count equals 2, so we just need to verify the swap. So suppose the corresponding two indices are I and j, so we need to check si equals go j and sj equals go I, right? So that's the overall procedure. So with that said, let's look at the code. So once we make it clear for the steps or the logical hierarchy, so we can actually write a very short code. But here, so for clarity, we are going to write with some redundancy, I would say. So here I'm going to initialize a set. So in this case, this set is going to check how many different indices correspond to different characters in S and Go. So also I want to make a count variable that is 0, count this indices. So also we are going to use a early stopping, right? An early stopping if count is more than 2, so we are going to return false directly. So here we just need to iterate, because we are going to use the indices. We are going to use enumerate function, and also we want to compare the corresponding positions in S and Go. We are going to use the zip function. So for I, so character from S and character from Go. So in enumerate. So here I'm going to use zip character and not character S and Go, right? So we are going to compare, right? If character S does not equals to character Go, then we are going to add this index to the set aux, and then we are going to increment the count variable by 1. So here let's make an early stopping criterion. If count is greater than 2, so we just need to return false, right? So afterwards, if after the for loop there's nothing returned, then the count variable has 3 possibilities, that is 0, 1, and 2, right? Actually, first we can compare the length. So if we use the above procedure, so let's do this. If let's see, if length S does not equal length Go, and in this case we are going to return false, right? And then we look at the other logic. So once we finish this if check, then below, so we will assume S and Go have the same length, right? And then in this case, if count equals 0, so in this case we just need to check if S or Go there is a character which appears more than once, right? So this actually can be easily done using a for loop, or you can use check, right? So let's do this. So we are going to set the set of length S, so it does not equal to this, right? So if this length of the set S does not equal to length S, it means that at least one character appears more than once in the string S, right? So this is the short-headed logic. So this deals with the case count equals 0. So if count equals 1, so in other case, this count equals 1, so we just return false. And another case is that the count equals 2, right? So in this case, so we can actually get the 2 indices. So aux pop, so we use pop twice. So we get the 2 indices. Then we just need to verify the swap. So si equals go j, and as go equals as go sj equals go I. So that's the full logic for this problem. So this is the checking length, and this is get the count variable with early stopping. This checks the 3 cases, either 0, 1, or 2. So with that said, I guess we are ready to do the checks. So local variable g does not defined. So let's see where is g. Count else I g add g. So here I guess this should be I. Yeah. Yeah, it passes the AB BA case. Now let's look at AB AB. So this should return false, right? So AA should return true. Right. So now let's look at the generic case. Yeah, it passes all the test cases. So this problem is marked easy by Leetcode. However, this problem is an interesting one. So for this problem, making the logic hierarchy clear is important. So with that said, I guess that's about it for this easy problem and for this video. Thank you.